Hi everyone. In this video, we will work on practical 2 of chapter 8 in SolidWorks CAM Black Book. So we have already started SolidWorks. Now we will open the file. The file is available in SolidWorks CAM student resources of this book. So you select this one and click on the open button. The SolidWorks CAM add-in was already discussed in previous practicals, so you can refer to that. And in this practical, we are going to use automatic features of SolidWorks CAM to extract various machinable features and then automatically generate operations and toolpaths. So we will be trying to use the minimum manual options. We'll start with defining the machine. So in this practical also we are going to use the same mill metric machine. For post processor we'll be using the same Fanuc 16M post processor, and rest we'll click OK, and then we will check the coordinate system. Click on this one. Okay, everything is fine. You click on the OK button. Now we'll generate the stock. So we'll click on stock manager. Stock is automatically created. Z plus 5. So okay. I'll create a mill setup. For the direction, we'll select this face to define z-axis. Select the face and click on the OK button. Select this one again. Now click on extract machinable features. So all these features are getting added in this mill part setup 1. Now select this one and we will generate the operation plan. So operations are automatically created for various features that were extracted automatically. As you can see, there is no need to add any manual feature now. So select this one again and click on generate toolpath. So all the toolpaths are as well generated. So what is left is just run the simulation and check if everything is fine. Click on this one. We'll pause at collision and click on the run button. Let's just reduce some speed. There was a collision, rapid collision occurred, tool and stock. So let's see how much it is within the parameters. It is within the parameters. Oh my God. So there is a collision between the part and the tool. This is rough mill 4. So we will. Now if you look closely on these tool paths, then you will get that the face mill operation is not getting completely removing the material from these faces. It is removing material only from these faces and above that. So the main problem starts here, and the feature for this face is this one. So we need to create another feature that is capable of removing material from this area. So we will start with a new feature. Let's say 2.5 axis feature, and we will create an open pocket. Select this one and then click on AND condition. Blind is also correct, and if you want you can go to up to faces or up to the stock, that will also work. Now click on this island and select this face and select this one. Now click on this OK button. So we have created another feature. It's an open pocket. Let's drag and place it below this face feature, and now we will create an operation for this one. So we are going to create an operation, generate operation plan. So it has created two more operations. Generate, let's drag it below this face one. Okay, now we need to generate the toolpaths again. So generate tools, so now this rough operation is removing metal from these faces as well. And similarly contour is performing operation here. So now let's again run this simulation. Now here we have a collision between rough mill 3, tool shank and stock. So the simple reason for that is the length of tool is not enough. So we'll go to rough mill 3. Rough mill 3, we will edit the tool. We'll increase the length of tool. We'll increase this one and this one, and hit OK. Generate the toolpaths again and run the simulation. So again this time it is colliding with our stock again. So one of the options that we can use here is to add an avoid. So new avoid region, and we select this one and hit OK. Now generate the toolpaths again and simulate. Now it's with rough mill 5, the same problem, tool with the stock. So it's the same way, we can add new avoid region. We'll add this and we'll check the length of the tool as well. So we'll add it in the definition. Let's slightly increase this one. And regenerate the toolpaths and simulate. Tool shank and stock, same issue, contour mill 3. So we need to add a void region here also. New. And same tool length issue. Well, we need to remove this avoid area. Oh no, this one. Okay. Now after running this simulation, you'll get to see that the circular pocket is not getting completely machined. You see, the material is left here. So one of the reasons for that is the diameter of tool. Let's say which operations are cutting this area. So these are the two operations that are machining this area, and I think up to rough is also not correct. So we will change the tool for these operations. We'll simply use 10 mm flat tool from the crib. Dia capable of machining this area is 9.97, so we need to go lower than that. For rough machining we can use either 8 or we can just go with this 6. So we select this 6 one and click select. Yes, change the holder. Now we need to check the length. Is it enough? Yeah, it's enough to machine, I think. Okay. So now you can see that it's machining the bottom portion as well. Similarly for the contour tool, you need to change the tool. Same tool grade. Yes, and okay. So now we'll regenerate the toolpaths. Now we'll rerun the simulation. Again, tool and stock collision. So what can be the reason? Well, this is a simple one. The length of tool is not enough. Okay, let's check the depth as well. To this one, measure, select this face and select this edge. Delta Y is 20, so up to 20 length is enough, and we have 25, so this should be fine. Tool and stock. Drop mill 1 operation. Who has left the material here? I think the issue should be the pattern for cutting, so I'll select. Okay, if we'll select this barrel out, I think this should solve the problem. So hit OK button. Let's regenerate the toolpaths and rerun the simulation. Well, this solves our issue, and we can generate the toolpaths as discussed in previous tutorial.